back. Day 2, this is actually take number 2. I didn't like the way it was going the first one, so we actually had some special guests come in and say hello. Unfortunately, I had to cut it because I didn't like the way it was going. It was getting a little too much, I think, for one video. So I'm going to try and keep it a little bit more simple in this video, and then we'll talk a little bit more in class about some of the little intricacies of it. This is where we left off with your notes. It says, due to the fact that A pairs with T and G pairs with C, one side of the DNA strand is given, you can actually determine what the other strand is. We've done this in class enough, but I just want to make sure you understand the vocabulary. Each strand of DNA is then said to be complementary. This complementary is not like you tell me that you like my tie or that you think I'm the best teacher ever. Complementary is that one goes with the other. So I have a few students in the room that I would say complement one another. It's spelled with an E, not with an I. If you say that you like something, that's with an I. Just a little English background. To simplify a strand of DNA, we don't draw it as detailed as you did yesterday in yesterday's lesson. The only thing that really truly matters is that nitrogen base, because that's the only thing that varies. The sugar and phosphate are identical at every nucleotide. So you can draw it one of two ways. From left to right, there's my backbone. The backbone is repeating sugar, phosphate, sugar, phosphate, sugar, phosphate. You can't see that in that detail, but that's what that line represents. And then what they have is the drop down of the different nitrogen bases. So I can make this up. I can tell you that this is A, C, C, T, G, A, C, G. You know, I obviously just made them up. The complementary nature of this says you can predict what the other strand has to be. So we'll do this. This is where you can say things aloud and you're in your room. So if you get them wrong, no one knows. If this is A, the complementary strand has to be good. Keep going. I can hear you. Louder. Louder. I don't hear you. There you go. And fine. Good. The last thing you can do is, if you want to be truly technical, we can draw those hydrogen bonds. Not everyone, I'm not going to do it for everyone, but to show you, remember, A to T, they have 2 hydrogen bonds. They have 3. So you can draw more detail if you want. I'm not going to see that. You're not going to see that very often. The last piece is, I can't really technically identify 5 and 3' from this diagram. So what they have to do is they have to give you at least one corner of it. So if I said this is 3', can you predict what the other corners have to be based on knowing the structure of DNA? Can you? What should be right here? 5', good. And then opposite the 5', this has to be the 3'. Opposite here has to be the 5'. Alright? So therefore, you can predict these 3 squares just because I gave you that one. From your basic knowledge, if this is the 5', you can remember that this must have that phosphate group hanging off. This side doesn't. The 3' doesn't have the phosphate on the outside. It actually is the sugar. Over here, 3', there's the sugar, and this will be the phosphate. Can't see all that detail, but you can infer that it's there. Alright? So what I'm going to do is I'm actually going to stop at this part because I don't know how the second part is going to go, and so this is the second time. This is pretty easy to get. So I'm going to pause it. It'll be a 2-video upload. Alright? So take 2, video 1.